Okay, sketch the graph of y equals tan to the minus 1 of x. Now this isn't restricted, okay? The tan graph is not between minus 1 and 1. It's actually for all numbers, all the numbers on the x-axis. Because if you think about it, tan x, when you draw that, well, that's not limited, isn't it? You know, it's not between minus 1 and 1 like cos and sin x is. It goes to infinity and minus infinity. So all you've got to remember is, right, when you draw it, if they ask you to draw this, is here you're going to put minus pi over 2, and the upper limit then is pi over 2. Because if you think about it, at 90, tan 90 goes berserk, doesn't it? Okay, it goes to infinity, and the same sort of thing goes on here. Okay, so just change it all around, have 90 degrees on this axis, draw an asymptote here, draw an asymptote here. Okay, this is just something to remember, it's unlikely to come up. Tan to the minus 1 of 0 is 0, so that's one value I can give you, okay? But then what happens is, it kind of goes like that, okay? That's tan to the minus 1 of x. Positive gradient, yeah, because when you see the formula booklet, you got that, haven't you? That's the derivative of it. Part B is really nice, right? You don't have to justify anything here. So basically, to differentiate this, it says, doesn't it, you know, take the tan to the minus 1 over, so you get tan y, so x equals tan y. Differentiate, it's really nice because x becomes 1, tan y becomes sec squared y dy dx. So you get then dy dx equals 1 over sec squared y, okay? Going back then to first principles, you know, from before, sine squared plus cos squared is 1, okay? Now, if I now divide by cos squared, okay, we'll get a different result out. If you remember, divide everything by cos squared. Sine squared over cos squared is tan squared. Cos squared over cos squared is 1. 1 over cos squared is sec squared y. Okay, so then this becomes 1 over sec squared is tan squared plus 1. Okay, and of course then you know tan squared is x. It's going to be x squared, isn't it? So x squared plus 1, and you get your result.